All right, let's dive right in. Today, we are talking all about mechanical engineering. But I want you to just forget everything you think you know about it. You know, the greasy gears, the clunky pistons, all that old school stuff. The entire field has been completely flipped on its head by a digital revolution. And we're about to look at what's really going on behind the curtain. So, quick question for you. When I say the words mechanical engineering, what's the first image that pops into your head? Is it some giant roaring engine? Maybe a massive factory assembly line? Whatever it is, I want you to hold that thought because we are about to give that mental picture a serious update. And wow, this slide just lays it all out perfectly. On the left, you've got the old school stuff we were just talking about. Gears, heavy machinery. But look at the right. This is the new school. We're talking digital twins, artificial intelligence, collaborative robots. We've literally gone from smashing metal into shape to 3D printing space-age composites. This isn't just some small step up. It's a completely different game. This is the new reality. So how in the world does this all work? Well, we've broken it down into three main parts. First up, we're going to talk about the brain. You see, a modern factory isn't just a building full of machines anymore. It's a smart, interconnected system, and it's all run by some seriously powerful digital intelligence. A huge piece of this digital brain is something called the digital twin. Now, what is that? Imagine having a perfect one-to-one virtual copy of your entire factory running on a computer. You can test out new ideas, predict when a machine is going to break, and fine-tune everything for maximum efficiency, all without ever touching a single real-world bolt. It's kind of like having a flight simulator for your entire manufacturing process. It's a total game changer. And AI is the engine that makes this digital brain so smart. And it's not just one thing. It's a whole toolkit of incredible abilities. I mean, look at this list. You've got AI fine-tuning CNC machines to get a perfect finish. You've got neural networks in food processing figuring out the best way to purify juice. And get this, there are even algorithms that can just listen to the sound a machine is making, detect a tiny anomaly in that sound, and predict a failure before it happens. This isn't science fiction, folks. This is happening right now, making everything smarter and more reliable. So, what's the payoff for all this smart automation? Well, it's pretty clear, and it's massive. You see, productivity go way up, product quality goes way up, and at the exact same time, manufacturing costs go down. It's the trifecta. This is the powerful business reason that's pushing this revolution forward so fast. Okay, so we've talked about the digital brain. Now let's get physical. Let's talk about the advanced body. What are we actually building all this stuff with? Well, the answer is a whole new generation of materials and processes that are lighter, stronger, and way more capable than anything we've had before. And at the heart of this is something you've definitely heard of, additive manufacturing, 3D printing. The old way was to take a big block of metal and just carve away everything you didn't need. But with 3D printing, you build the part from nothing, layer by tiny layer. This completely unlocks the ability to create these incredibly complex, lightweight parts that were just impossible to make before. Honestly, the toolbox of materials an engineer has today is just mind-blowing. We're talking about everything from composites made with natural plant fibers to heat-sensitive alloys like nitinol that literally remember their shape, to ultralight, super strong stuff like Kevlar honeycomb cores. It's not just about building things anymore. It's about building them with the absolute perfect material for the job. And the level of detail we can achieve now, it's just astounding. Take this process for polishing diamonds. It's not just grinding away. No, it's a two-step dance. First, a mechanical polish, and then a chemical one to get a surface that is flat, down to the level of individual atoms. That's the kind of insane precision you need for the high-tech components in all our modern gadgets. Okay, so we've got a smart brain, and we've got an advanced body. But how do they all come together? Well, that brings us to our third and final piece of the puzzle. The collaborative system, which is all about how humans and machines are finally becoming true teammates. I want you to meet the cobot, which stands for collaborative robot. Now, unlike those big, scary industrial robots you see locked away in cages, cobots are designed to work right next to people, out in the open. And here's the most important part. They're not there to replace human workers. They're there to augment them, to help them, to be part of the team. And this quote really gets to the core philosophy here. The whole goal is to enhance what humans can do. You let the cobot handle the tedious, repetitive, or physically exhausting work. That frees up the human operator to focus on what we humans do best. Complex problem solving, dexterity, and quality control. And here's a perfect real-world example of that teamwork. So, the human operator places the main housing. Then the cobot zips in and does the boring but super precise job of fastening all the screws. Then it's back to the human to do the tricky wiring and give it that final quality inspection. It's truly the best of both worlds, making everything more efficient and a whole lot easier on the human worker. Of course, anytime you have people and powerful machines working side by side, the first thing you have to think about is safety. And you better believe it is the absolute #1 priority. You can't just throw them together and hope for the best. Every single task, every movement goes through intense risk analysis to make sure that this collaborative workspace is as safe as it is productive. So we've looked at the digital brain, the advanced body, and the collaborative system. Let's pull this all together now and talk about why this huge shift in mechanical engineering actually matters to all of us. This table is a really great way to see how it all connects. You have the digital brain, giving us products that are more reliable and more affordable. You have the advanced body, making things like our cars and phones lighter and stronger. And you have the collaborative system, which creates safer jobs and higher quality manufacturing. It's these three pillars working together that are truly building our future. And please don't think this is all just some abstract, far-off theory. This is the hidden reality behind the things you use every single day. The tech we've been talking about, it's what makes the smartphone in your pocket possible. It's inside the advanced medical equipment that saves lives. These innovations are the invisible engine driving modern life, constantly pushing the boundaries of what we can do. So I'll leave you with a little something to think about. As all these incredible technologies keep getting faster and smarter and start blending together, which everyday object that you use right now do you think will be totally, completely unrecognizable in the next 10 years? Thanks for joining me.